Hello, everybody. All right, welcome to this second to last episode of this room here, at least at Build. So thank you for being here. My name is Matt.
I'm Nick.
And we're here from the Visual Studio team to talk about Visual Studio and Copilot in Visual Studio specifically. Now, we could talk about all sorts of things, Visual Studio and features in Visual Studio, what's coming and all that type of stuff, but this is specifically about the Copilot pieces. And we have some cool demos, and we're going to talk about roadmap, what to expect, what's coming down the pike here over the summer. And just to frame this a little bit for everybody here. When we're talking about Visual Studio, because we get this question all the time, we got it at the booth here through the conference as well, how does Visual Studio fit into this new agentic world? And it worked great. So if we look at what Visual Studio is and how we see it and how we see its positioning, it is the tool for professional C# and C++ developers on Windows. That's what it is. So if you're doing that, this is the premier place for you to do your development today and tomorrow. Right? Whether you're coding all day long or you're doing a bunch of agents that do the work for you or whatever it might be, this is for you. Okay? Now, we have a bunch of other tools. If you're doing Python or Node.js and stuff, we have a bunch of other tools for that. VS Code is fantastic. And so are other tools, whatever makes you happy. But if you're using C# and C++ as a professional developer, Visual Studio is for you. Because there are certain things that makes Visual Studio really, really good for professional developers, because a professional developer does things a little bit differently often. We have to think about quality gates. What does the code look like? Like security, accessibility. There's all sorts of compliance and governance. There's administration, like IT admins that may have a say on what the rollout of Visual Studio across their fleet is supposed to behave, group policy, and so on. So this is something that's specific to pro developers, and it's something that Visual Studio is really, really good at. And it will continue to be a high priority for us. And there's something to say about code quality, especially in this new world of agentic development where you don't always write the code, but you definitely review it, right? So you might have an agent do some of your work, writing the code, but then how do you maintain that code quality, coding standards, and so on? And sometimes that matters, and sometimes it doesn't. The way we see it, when we talk about this distinction is code an asset? Is the code something you have to maintain for years to come? Maybe a whole team is working on it. Coding standards matter, formatting, and quality, all sorts of things, because code itself is an asset. Versus the other one where it's, OK, I'm writing some proof of concepts or internal tools where the code is an artifact. It's the thing I'm producing, and I don't really need to read it that carefully, or in order to maintain it, I'm fine with just the agent doing that. That's when we say that the code is an artifact. And from Visual Studio's point of view, if you see code as an asset, then Visual Studio is for you. Okay? This is where we're like very, very serious, and where we're seeing our investment go for professional developers that see code as an asset. And we have some cool demos. Nick, he brought some really fancy stuff that I'm really excited for you guys to see. And so let's cut over to the demo.
Cool.
There we are.
So when Mads talked to me about coming in for this talk, he said, we got to show something for the professional developer. We got to show, what is actually real. What are people going to encounter every day? And so I thought, what more fun could we have than to actually work on Visual Studio inside Visual Studio? And so this solution that I have open is the Diagnostics Hub solution, and this is the code name for the Visual Studio Profiler itself. This thing gets built, packaged into Visual Studio, and this is what gives you access to all of those profiling tools that you enjoy in Visual Studio. And this solution, this component, is written in C++, it's written in C#, it's written in JavaScript, it's got some assembly and some IL. If you look really deep down, there is a lot to it. And so we need professional tools to actually be able to work on this. And so what better way to demo the power of Visual Studio than to use this? And so I want to walk through an actual bug that came across my plate a couple of months ago. And this was an internal telemetry bug that got filed on us, where we have this index out of range in hybrid dictionary enum keys iterator. We actually worked on a new feature in the profiler. We added it in, and then when some of our internal dog fooders started using it, we started getting a couple of crash hits, and this bug was filed, and it was sent over to me. And I went and I had to go fix it. And normally I would, look at the stack trace, I would start digging in, and I would try and figure out, like, hey, how is this happening? Why is this happening? But now with a lot of the new agentic powers that are in Visual Studio, I can use that to help me be more efficient in actually working through this. And so I copied that link real quick, and I'm going to hop over to the Copilot chat. And one of my favorite new tools in Copilot is access to the MCP servers.
Oh, yeah.
They're great. I have this tool that's super powerful, and I can use these MCP servers to tie into all these different endpoints. And one of my favorites is this new ADO one. And so with this, I can say, hey, we are getting a crash noted by this bug. And the nice part is I can just copy and paste the bug link in. And then I can say, write me a unit test that demonstrates this bug. And now Copilot's going to go ahead. It's going to go and access that. And right away, you can see it tries to use the MCP servers. Again, Mads was talking a little bit about that governance. I can't just turn it on autopilot YOLO mode. Like, I have to be in control of what's actually happening on my system. It's using my credentials to access these things.
Well, hang on. You could put in autopilot, right?
I could. I could. I like to be in the loop. I like to understand kind of what's happening.
Yep.
And so you can see it's trying to do this get work item. I'm going to go ahead and I'm going to confirm that, and I'm going to say, hey, that's fine. And so it's going to fetch that work item. You can see it just grabbed an auth token. We'll go ahead and close that. We'll flip back, and it's already seeing, like, hey, look at the hybrid dictionary source, and let's look at the existing test structure. So it already picked up on the stack trace that was in there. It noted that there's problems in hybrid dictionary, and then says, let me find the tests for it, and let me try and go and write those tests. And so it's continuing to dig through. It's just gathering more context. And you can see it's already implemented a test for me. Now, the interesting thing is this bug came with a new feature. We didn't actually have any tests for this hybrid dictionary. And these code paths where this is starting to crash, it was in code that was never used, and this new feature made use of that code, and that's why it started to crash. And that's why it was never caught in code review.
We all have code like that.
Yeah.
Just hanging out, yep.
So I'm going to go ahead. I'm going to keep all these changes. These look great. And it gave me two new test methods, one to enumerate the keys and one to enumerate the values. And then I'm going to flip back over to my solution. I'm going to link over to where it is. It found my data warehouse managed suites test project. This hybrid dictionary was in our data warehouse component. I'm going to go ahead. I'm going to say build.
So this is the actual code that's in Visual Studio. It's one of the many packages that make up all the different features of Visual Studio.
Yep, exactly. Yep. And looks like there was a build issue. Maybe. Try this one more time.
One failed.
One failed. Oh, hey, look at this. The type string must be non-nullable value type. It looks like what's happening is this is supposed to be using some sort of struct for the key, so that was nice and fast. I can just tell Copilot, hey, those don't compile. It looks like it's the wrong key type. And I can kind of continue to have that conversation with it. Hopefully it's going to go ahead and fix it. It's going to look into what key constraints exist.
But what I really like about this, your approach here is that you're writing the test first.
Yes.
To reproduce the issue. Mm-hmm. Why do you do that?
So I never actually believed in test-driven development until Copilot came along.
Okay.
Like, it just felt awkward. Like, I wanted to write the code, and then afterwards I might write in a couple of tests to see, what can I do to protect myself from code failing in the future. Now I look at this more so in terms of I can write these tests to kind of create this nice test harness, and then I can let Copilot actually help me write and author the code that's going to fix those tests.
Yeah, it gives you like the safety of having the harness, the guardrail in place when you let loose the agent to work on your code.
Exactly, exactly. And the nice part is you get this like durable artifact that goes with your repository. So then in the future, you start doing more refactoring with Copilot, or you're changing out different dependencies. You have this nice test bed that you can then fall back onto. And now it looks like our build succeeded, which is awesome. So now let's go ahead and let's find this in our test explorer. So I'm going to say, I'm just going to copy this. So I have my test here. I'm going to run it, and hopefully, with any luck, this test is going to fail, and it's going to reproduce the crash. And it's running. So this is the challenge of working on large enterprise software.
Yeah.
There are hundreds of projects, and stuff isn't always instantaneous.
There we go.
But we can see it's running now. The build succeeded, and sure enough, it failed.
So this is a success.
This is a success.
Yes, this is what we wanted.
But actually, this is really interesting, because the test detail summary, if I look at that, my original bug was it should throw an index out of range exception, right?
Uh-huh.
And it's not throwing that. Instead, it's saying it's failing an assert. And so this is not what I would expect. So I'm just going to go back to Copilot and say, it's not throwing the exception. It is failing with.
This is very real-world type of stuff, right?
Yep.
You go and you try to create a test to reproduce, and you discover other things that could be problematic.
This is literally what my day-to-day looks like. It looks like it says it needs an extra element. Would you like me to go ahead and apply the fix? Yes.
That's nice. All right.
Yep. Actually, when I said yes,
it's fixing the test itself.
No, it's fixing the code.
Okay.
So
it's
I'm
not
going to say
supposed to fix the code yet.
It's not supposed to fix the code yet.
Yeah.
Fix the test so it fails with index out of range.
This is the thing when so you actually practiced it, but because this is AI, you kind of never know.
Yeah.
Right?
No,
so you get different runs every time. Yeah. That's the nature of it.
The working in the non-deterministic,
right, but
probabilistic.
It's a really good. It's a really good way of looking at this because you were able to see what was going on, and so your skills, your expertise is what helps you guide the agent to do the things that you know that it needs to do. So the better you are at your job as a developer, the better you are at managing your agent too.
So now it's gone ahead, it's updated those tests. So let's run those tests one last time. And with any luck, hey, we're failing with our index out of range, which is awesome.
Nice.
Actually, I think that's the first time I said it's awesome that our tests are failing. But in this case, I'm actually happy, right? And so now I can start to lean into even more of the Copilot features of it. So I have this nice guardrail. I have this nice test harness in place. And this is really where I can let the agent cook. I can say, like, hey, this is the problem. Go ahead and fix it. And we got to doing this so often in Visual Studio that we're like, hey, go optimize this benchmark. Hey, go fix this test that, hey, let's just go put a nice shiny button for people to click, and let's just make it nice and easy. So I'm going to do my clicky in the UI, and I'm going to say, hey, debug this test with Copilot.
So you just right-click the test and say, debug this test.
Exactly.
With Copilot.
Yep, exactly. And so now it switched over into our new debugger agent. And so we've gone from the regular agent mode, we're now in this debugger agent, and the debugger agent knows how to use the debugger. It can set breakpoints, it can hit those breakpoints, evaluate expressions, it can look at memory, and really start to understand the code. In here, it gave its hypothesis, and it said, hey, the bug is clear. Turns out we had an off by 1 error, and it's very specific on the number of elements that are in that collection. And so it went ahead and fixed it, but then it went and it reran that unit test. It ran it under the debugger, so if a problem did occur, it could catch it. But after it applied the fix, it noticed that the test passed, and we're good to go.
Nice.
And so this was legit a problem that we had. It came out, I think I want to say it was the 18.5 range. And we caught it internally before it started affecting
18.5 was that the April update?
I believe it was the April update. That sounds about right.
Yeah.
And so we caught it before it started affecting users. It was affecting our internal users. We're able to use Copilot to author that fix and push out that fix.
Nice.
So.
And so anyone, like before, you could also go in and right click and say, I want to debug the test, right? And you could set your own breakpoints, you could do your own debugging.
Yep.
But you said, hey, instead of me doing that manually, I'm going to let Copilot do that. And off by 1 errors, I mean, we've all been there. Sometimes they take forever to find, even though they're simple in nature. And so something like this can really speed up even the simplest things, right?
Exactly, exactly. And so the second demo I want to kind of show is our new profiler agent experience. So one of the awesome packages we recently added was our VS Test performance collector. And so what this is a NuGet package. You can add this to your test runs. We added this onto our Azure DevOps test runs. And so every time our unit tests run, it automatically collects a profiling trace for us, adds it to the test attachments.
What is a profiling trace?
So profiling trace, when that test is running, it'll start saying like, hey, I'm about to execute the tests. We will turn on the profiler, and it's going to start collecting information about where your program is periodically throughout its run. And then at the end, it'll say, OK, I'm all done. It'll save all of that data it's collected, along with auxiliary data like debugger symbols, metadata from .NET. And then it can take all of that, and it can present a report to you that basically says, like, here's where your program spent the most amount of time.
So like CPU cycles, memory allocations, object allocation, that type of information?
Exactly, exactly. Yep. So we can capture CPU data, like you said. We can capture allocation data. And we're going to demo this in Visual Studio, where we're going to use actual instrumentation, and we're going to use dynamic instrumentation. So actually what's going to happen is that unit test will start up. It's going to then hook into the profiler, and the profiler is going to instrument your code with start and stops between all your method calls, so we can get exact performance information that we can use to then determine where we should apply fixes. And so I was saying we recently added this to our Azure DevOps PR runs, and we noticed that we had this express decode large file. Yep. Code large file. We had this decode large file unit test, or verify large file, which basically compares how quickly we can compress and decompress a diag session that has one of these ETL files in it. Diag session is the format of that trace file that the profiler collects.
So whenever you open a profiler trace in Visual Studio, like it's reading that file to memory?
Exactly.
Yep.
And so when we started running those unit test trace, it said, hey, you're spending most of your time in here. And so I want to go ahead and I want to make that faster in the profiler. So I'm just going to, again, I'm going to right click and I'm going to say profile with Copilot. Because again, I could specify like, hey, at profiler, I want to go ahead and I want to run this unit test and I want to make it faster. We're doing that over and over and over. And so let's make some clicky buttons that I can click on stuff and I can get into my scenario.
OK, but so you said profile with Copilot, but you can also just have said profile.
Exactly.
So if you want to do all this yourself and dig into the data and get your hands dirty, you can totally do the same thing?
Totally do the same thing.
Yep.
In fact, we technically don't have to show the UI here. Copilot doesn't necessarily care that the UI pops up and that you can browse through it. We present it because we want you to be able to dig into the UI if you want.
Yeah.
You can actually help steer the conversation with Copilot.
Super important. And so you get to understand what's going on as well.
Exactly,
Yeah.
exactly. And one of my favorite things that you can do with Copilot, after it's done one of the optimizations, you can ask it why. Why is this faster? And you can learn as a software engineer, like, oh, hey, I've learned so many tricks about the JIT, the GC, just asking Copilot, like, why is this suddenly so much faster if I do it this other way?
Right, because it knows all the low-level stuff. Like I know how to write C#, but I don't know unsafe C#, right? I don't necessarily know why one type of list or dictionary is faster than another type.
Yep.
And so that it explains that to me is super helpful.
Yeah, yeah. So we ran the trace, and Copilot did an initial analysis with the findings. I can kind of look at the trace myself. I can see, hey, this took exactly 3.88 seconds to actually run the unit test itself. It was doing some express stream test stuff. It was doing some hashing, and you can see where it's reading bytes. And then in the key findings, it's saying like, hey, the hop path is dominated by this frame, this express stream.read block, and it's hitting this check read enough bits function all the time. And I'll be honest, I was the one who wrote this code, and I can tell you, I profiled this code a ton. I was the dev lead for the profiler. I had to use it all the time. And even though I've profiled it over and over the years, there's still optimizations to find in it. And so Copilot's gone ahead and it's given me helpful suggestions here. It says, hey, I can optimize this express stream read block to buffer reads and reduce the binary reader overhead. I'm going to just click that and say, yep, go for it. And so it's going to go off. It's going to read the context on that. It's going to try and find like, hey, where is the source code? It's going to look at the line information, match it up with the profiling report, and it's going to know exactly what it needs to go and optimize.
Yeah, so what's really nice here is like it doesn't guess from the code. Like it doesn't just look at the code and say, oh, this looks like it could run faster if you do these things. It looks at it's actually executing code to figure out what the issue was, which is much stronger scientific case for the optimization, right?
Exactly. It's using actual data. So one of my favorite sayings is, if you're not using data, you're not actually profiling or improving performance, you're just refactoring.
Yeah, right.
So it's gone ahead, it's implementing some changes in Express Stream. You can see, looks like it's creating this new byte buffer. It's updating some Huffman table, read table, so some really low-level compression code that's used to compress these big diag session files. It's adding that, and then with any luck, it'll go ahead, it'll build stuff, it's going to run the test again to make sure that it doesn't fail, and then it's going to reprofile it again to validate that it improved.
So with success, Visual Studio will be faster after you commit this code change.
Exactly. We've actually...
we all get to benefit from this.
We do. We do. I think since we've added this new test collector, I think we've had 6 or 7 different PRs into this diag session reader. We've over doubled the performance of reading these files in the latest versions of Visual Studio.
Okay. Yeah, I do remember back when I started using the profiler. It's something you do after you do your code, and it can take minutes to run, and even just to open that file takes minutes, and so it's something that becomes an afterthought. It's not part of your inner loop, dev test, build run cycle. It's something you may do after the fact if you remember. But because it's so fast now, I can do it as part of my inner loop. I can just start a new session and see whether I had any regressions.
Yeah.
And I would know a minute later. It wouldn't be like this long process, right? Yeah.
And it's always, like you said, it's one of those afterthoughts. Like people are interested in, how do I get new features out? How do I fix bugs that are crashing? And then we start to kind of let the code degrade over time because I just got to add more and more to it, and people aren't screaming at me yet for performance. And it takes time, and it's a lot of data to try and understand. And now that you have kind of a partner to help you dig through that and help you understand what it is that you're looking at and suggest different optimizations is just great.
So that NuGet package you were talking about that you add to your project that helps you run your CI runs, to give you the benchmarks.
Yep.
you get the Diag sessions, so you have data like on your CI runs. You can now see if anything slowed down, you have any regressions.
Exactly.
And you can then take that file.
Yep.
And you can just open it in Visual Studio and see exactly what the problem was.
And so I could download that file and I could see it.
Yep.
I could also use those ADO MCP tools that I showed in the first demo to have it automatically go out, find that file for me in this test run. Like I can say, like, here's the URL for the test run, or here's the URL for my pipeline. Go find any Diag sessions you can find, go analyze it in the profiler, and tell me what I can do to optimize my code.
Oh, wow. That's amazing. Amazing stuff. And this is something everybody can just go ahead and do. And we were talking about this. We've never heard of anyone that, like, on their own, if you go and improve the performance of your app, like, it's one of the few activities we can do as developers without having to ask permission first, right? We don't need to have a ticket, a Jira ticket, or a GitHub ticket to go improve the performance. It's like, good job.
Yep.
Thank you. Thank you for improving the performance, right? It's always a good thing.
So it's going through another build of the solution. Again, this is the challenge of big enterprise code.
You could have used the solution filter for this one, maybe, Nick.
I was thinking about it. It's something that we recently added. The thing is like, I like showing that there's 160 different projects, and this is as real as it gets. You know, it's C++ code, it's C#, JavaScript. So
160 projects, and it's only the Profiler and Diagnostic Hub?
Yeah, it's the Profiler and it's the Diagnostic Tools window that pops up when you do debugging, you know, the pretty graphs. And
so if we combine that with all the other parts of Visual Studio, we have a lot of projects.
I think when we first did the conversion over from TFS to Git, it was like 400 gig worth of data inside of it. It was just a massive amount.
Wow. So it's running the build.
It's running the build. I'm hoping this is going to work and pass. While we're waiting for that, we can kind of review some of the changes that it did. So it looks like it did a pretty extensive amount of changes. And the interesting thing here is we were reading from this input stream using a byte reader. And that's really fast. Like, it's the fastest way to access a byte stream in .NET. And it's still like, hey, that it thinks it can do better. And so what it ended up doing is it read it into this new byte array that it then just can directly read from. And it actually reduces the cost of the calls into the byte reader.
That's amazing. That's like stuff that you would probably never think of yourself, right?
Yep.
You would just see the profiling trace and be like, oh, yeah, but it's already optimized. It's using that reader, and it's super optimized as it is. There's nothing for me to do. OK, so the build succeeded. There are some errors from unrelated projects, again, as real as it gets. It's now running the tests. And so it's actually profiling it again. So it's profiling again?
Yes. So that's one of the biggest things. I always say optimize twice, or measure twice, optimize once. You measure to establish a baseline. Then you go and you make some changes to your code, and then you measure again because you want to see the impact of the changes that you're making. OK,
and so it was the one that now executed the unit test again with the profiling attached, or to create the Diag session?
Exactly. Yep.
So it's just one seamless flow, basically.
Yep. Because it knows that you need to, in order to do a good scientific performance optimization, you have to do that measure before and after.
Right.
You need to see the impact of the changes that you're doing.
Yep. Yeah, 160 projects. Sometimes it takes a while, huh?
I know. I think Test Explorer also kicked off a build, unfortunately.
OK. Yeah, that's how it goes sometimes. That's just how it is. I like the way we're approaching this where, you know, remember back in the day with HTML5, it came out, you had this idea of progressive enhancement. So you would create your website, it would be basic, you would be able to like click the links, it would change to a new URL, and it would load everything. And then Ajax came along, and all of a sudden we could partially load pages, and then, you know, React and Angular, and more stuff came on top. And if your browser was able, at the time, browsers weren't very able to do anything, but as they became better, you could take advantage of all these features on top of the basic layer. And that's kind of what we're doing here, I feel like, with some of these Copilot stuff, where we come in and you can be the driver. You can do everything manually if you want to. You can completely be in control of everything just like you have so far. But you can take that extra step atop that with Copilot to really push the limits.
Yep.
I really, really enjoy that. So you can, sometimes you may want to have the Copilot experience, and sometimes you don't. And you can decide.
OK, so it just ran the 3 tests. So here's the interesting part. It ran the tests ahead of time because it wanted to make sure it didn't regress any of the behavior. And then it's profiling again. So again, you get these really nice guardrails with it.
Yes.
So you can really let it go and cook, if you will.
Right.
And with this, it looks like we're getting another profiling trace out. And
Gonna give us a new chart. That looks different. It's more green now.
it is more green now. Time has shifted in there.
Yep.
And we're at 2 seconds for running that performance test.
OK.
When previously, we were at 3.8. So we almost doubled the performance of running that test, which is decoding one of these large files here on stage.
Wow. Awesome. That is fantastic. So this is something everybody can do. You can go home and do this, right, on any code base, .NET, C++, whole thing.
.NET, C++, whatever you have.
That's awesome.
So
Wonderful. This is great stuff. So yeah, I encourage everyone to go try this if you haven't already. It's really, really powerful stuff. All right, let's switch on back to the slides. So Nik, you ran this. You told us you've run this now on the Visual Studio code base, but you run it on other things too, right? We ran it on Visual Studio itself, like Profiler. You were telling me about was it the startup? You found like 80,000 allocations recently or something?
800,000 allocations in startup due to an Azure DevOps cache file when it's loading the version control library. The Profiler agent actually found it in via startup. I set up a Ralph loop and told it, hey, run devenv, allocation profile it, see what you can do. And there's this XML deserialization of this cache file, trimmed 50 megabytes off of our initial heap, 800,000 allocations, way less for the GC to do.
That's amazing. We turned it on to the Azure App Service. So instead of just doing Visual Studio, what other parts of Microsoft products can we look at? So an Azure App Service reduced the cost, basically, of running Azure App Services by optimizing the performance there. Roslyn, what did you do with Roslyn, the compiler?
We literally just did the Roslyn compiler, I want to say 2, maybe 3 weeks ago. Roslyn compiler has tons of benchmarks. People have been optimizing this thing for the longest time. We found an optimization in switch case evaluation. It was SDE2 on the team. It was like, oh, I'm going to download Roslyn. It's got some tests. I'm going to run through it, and I'm going to let the profiler try and chew on it. Sure enough, found it and got his first contribution out to Roslyn.
That's amazing. So this works on a wide variety of different types of applications and libraries and whatnot, whether it's UI or APIs or DLLs or whatever it might be, across the board. So that's pretty fantastic. Now, we got a bunch of stuff coming.
We do.
And we could talk about a bunch of the cool stuff we got for what do we got coming? We got work tree support coming next week, I think it is. We have full support for Git submodules coming next week in Visual Studio. It's kind of nice. But we're not going to talk about that. Yes, finally. But we're not going to talk about that. We're going to talk about some of the cool things we have for Copilot in Visual Studio. So a lot of us have to maintain old code, right? Whether it's old WinForms apps or web forms, web applications, and there's fewer of us left that are able to maintain that kind of code because it's old. You might have old web forms code that runs on .NET 3.0 or something, and who's going to maintain that and move that forward? It's really hard to go and tell and ask your manager or whatever, say, hey, can I get 6 months to convert this old web forms app to Blazor or something, .NET 10? Probably no is the answer. And we get that feedback all the time. So what's really cool is that we've had some really nice breakthroughs recently in our app modernization stories that now allow us to convert web forms, including user controls, server controls, components, into Blazor. So you can take those old apps and modernize them completely onto a modern stack. You can put Aspire on them as well, all through this app modernization. You can even upscale them to be something that can run in the cloud if you want to, and it's all handled by the modernization agent. So those are some really nice time-saving things that are coming for particularly this cohort. And a lot of enterprises out there have a lot of these old apps. Another thing we're looking at are agent skills. Now, the thing about agent skills is that they really make your agent workflows a lot more powerful. It makes them more useful, the agents themselves, when they work on your code base. The problem is, how do you find skills? These are just markdown files that live in like some plugin repositories or marketplace repositories scattered around the web. But how do you know that when you work on WinForms or some .NET scenario or whatever, what skills to use? That is a real big problem that kind of everybody's having. And what we're doing in Visual Studio is that we're automatically going to figure out, like, hey, what is it that you're doing? What type of project are you working on? And we have a bunch of skills that the individual teams have created, like the Azure team, the WinForms team, and so on. So if you're working on a WinForms project, we're automatically going to include into the context a bunch of these skills, making your agent way more powerful. Actually so powerful because it's written by the WinForms team themselves, right? The absolute experts in the technology you're using. And that's going to be applied automatically. So all these skills are really fantastic. They're out there. They're open source. We actually take a bunch of contributions from the community as well. And so they're skills you can trust, and we're going to automatically apply them. So very, very helpful to have this as well. Build speed. So one of the things that we do when we run anything in agents is that the agent will sometimes have to do a build, right? It happens quite frequently. What's problematic sometimes is that we can look at the error list and we see, oh, there's a couple of errors there, but it still tries to run a build, and that can take like 2 minutes to run before it hits that error, and it's, oh, build failed. It's like, yeah, I could have told you that. I saw that error before you started building. So we're doing a bunch of optimizations around all of it, but one of the first ones coming here is the build speed, where it does something as simple as, hey, let's just look at the error list and other indicators to see whether or not we should kick off a build now, or if we need to do a little bit more work first. So that's really nice that will come. That's going to speed up our experience. That is just one out of a lot of different performance optimizations that you're going to see around the chat window and all that. This is one of my favorites. So merge conflicts. How many people here love merge conflicts? Okay, there was a handful. Okay, good for you. So when we talk to a lot of developers, they tell us that they actually get a fear, and there's a anxiety and a frustration when you have to commit code and you realize, oops, I'm behind head and I have to do a pull first. And you're like almost shaking when you move the mouse up to that pull button, right? Uh-oh, can I do a clean pull with my changes or what, right? So there's a whole frustration there. And I get it. We all experience this from time to time. So what we're going to launch here very soon is a way to click a button and have the AI go and look and help us with our merge conflict resolution. This is a huge, huge thing, I think, for me and others that are, maybe except for that handful of people that love this situation, but that it has that ability to figure this out. And when we run the test against what would a human do when you're faced with a conflict, merge conflict, what would a human do? How would a human solve that conflict? And when we look at how would an agent do it, it's almost the same. Like the agent is very, very capable, and if it can't do it, you can always do the thing in that situation. You might have several merge conflicts, and only one of them is the one that require your input. Maybe none of them, right? So it really takes the kind of the heartache away, which is very exciting. All right, these are getting meatier and meatier, these features here that we're going to roll out. Have you ever thought about this as being a problem? Why is it that Visual Studio seems to be getting Copilot features later than everybody else? At least you don't have to put your hands up. I kind of know the answer to this question. You do, right? And we do as well. And it's kind of frustrating sometimes. There's a lot of reasons for it. But one of them is that we have our own implementation of Copilot. Like we talk to the Copilot, the Visual Studio talks to the Copilot API ourselves, and we have to like make it work with the profiler and the debugger agent and app modernization and all these different aspects of Visual Studio that a lot of other tools don't have. So that's one aspect. But another one is that we have our own implementation of the backend. Like we talk to the Copilot service ourselves. So what's really nice, what's going to roll out starting next week on the Visual Studio Insiders, is that we're finally going to make that move onto the Copilot CLI SDK, the GitHub Copilot CLI SDK. And what's really fantastic about this is that Visual Studio, VS Code, the CLI, like are all going to be using the exact same base, the same SDK. We're going to have the features at the same time. They're going to be implemented differently, right? Because in Visual Studio, we can kick off when the agent kicks off a build, it uses Visual Studio to do the build, which makes a lot of sense because MS Build is already warm, Roslyn is already doing its thing, and so that is actually executing faster than if we ran the build on the command line. So Visual Studio will still do its Visual Studio thing, even though it's on the shared component and SDK. So this is very, very exciting. I'm very excited to see what you think about this. I've been running it for about a month full time, and I absolutely love this experience. So can't wait for you to get your hands on that. We have one more. So we have a list of different models you can use in Visual Studio. Right? We got the Opus and the Sonnets and the GPTs, and we allow you to add other models. Like you can add, XAI and a few others. Got Gemini in there and so on. You can bring your own key. So if you have a subscription to some of these providers from a list that we've set that you can use, then you can do so. But you still need to sign in with your Copilot, your GitHub Copilot credentials in order to do this. And so I'm very happy to announce that starting very soon, you can start using any model in Visual Studio. Whether it's running local, whether it's on a cloud anywhere. Yeah, yes, thank you. There were some claps over there. I'll take it. Thank you. So this is a huge thing, especially for enterprises that have like very strict security requirements and so on. Maybe they can't run something that's in the cloud, for instance. Well, now you can run it local, whether it's on your machine, it's on-prem somewhere, your own server room, however you want to do this. There's not going to be restrictions there. But the thing that makes Visual Studio, as I was telling you in the beginning, is because we are so focused on the professional developer segment. We know that there are like trust boundaries and things that are important to enterprises. So of course, we're going to have a kind of a security layer there so you can lock it down for your organization to say, hey, only these models, or we mandate you use this and that model, for instance. And so you only use the local model, or you only use this cloud provider, or whatever it might be. Right? So you have that management layer on top. So hopefully you'll start checking this out again next week in the Insiders build of Visual Studio 2026. And I think we can take a question or maybe two. So if you have any questions, there's some mics up here. Come on up. We're almost out of time, but we do have a little bit here in case you're curious about something. No? All right. It was the back room that was having. But OK, let's call it here. Thank you so much, everybody. I hope you're excited about what's coming over the summer. Make sure to get the Insiders next week. You won't regret it. It's a lot of huge new things. So thank you very much.